2 weeks from today, you'll be starting your EOC. So, getting pretty close. About there. Let's start with this. We got a table here. We got bacteria growing in a petri dish. Just because I'm curious, anybody not know what a petri dish is? You'll see those a lot in science. You know, those little like clear-looking disc things. They're usually about, I don't know, maybe half an inch kind of thick. All right, so we got this table here. First thing we need is we are going to need to get a function for the table. So we got to put the table into Desmos. So everybody go ahead on Desmos and enter in that table. Like with some of the other things, it doesn't have to necessarily be the entire table always, but you make it accurate. And it doesn't take you a whole lot longer to enter in all of them either, you know. What kind of exponential. All right. So you always got to be careful for Math 1. With the 8th grade, you know, the tables are pretty easy. It's always like a linear function. But for Math 1, we got to kind of be careful because sometimes they sneak in exponential functions. Most of the time it's going to be a linear function, but we got to be ready just in case. Either way, it starts off the same. To get the function on the next line, we want to do our y1. We get the little squiggle line. For the exponential function, then, this is where it gets different. I put it as AB with exponent of x, and you got to remember, just like we got y1, we want to put x1. Now the subscript on the y and the x, the ones there, they got to match what your table has. When you first start off, your table will be x1, y1, okay? And what that's going to do is that's going to put the line on the graph. That's also going to tell you what A equals. That's going to tell you what B equals. All right, so that'll give you our function. So what does that tell us for A? So we got 3,699 point a bunch of stuff. So we're going to round that. We got about 3,700. That's what we started with right there. So our B value then, what's that give us for a B value? 1.03. So that means we're increasing by about 3% each time. All right, everybody good with how we got that function? So now we're looking at what it's asking here. It's asking how many bacteria will we have after 2 weeks? So we got two options. Once we have that in Desmos, once we got the table, we got days as our x value. So we can either do x equals on a different line, and we can put in 14 days and find where the two lines cross. You're going to have to zoom out a whole lot to do that. It's going to go up pretty high. That's probably not the best way to do it. Or you can take your function there, and we can take the x value and we can plug it in. So we can do 3,700 and take our 1.3 and give us an exponent of 14, right? Once we do that, when we have our 3,700 times 1.03 to the 14th, we get a 5,597. Okay? Any questions on that one? Again, pay attention. What kind of function it asks you for? Different functions get entered in different ways. Linear functions, we do the y1 squiggle mx1 plus b. That'll give us m, our slope, b, our y-intercept. This one, we got the y1 squiggle ab x1 for the exponential. We could do 1 a squared plus b c if we ever had to do a quadratic. All right, find the residual on that table. For x equals 51. Shane, what you got? Negative what? So negative 4.6. Enter in the table. You got to, once you have the table entered in, again, we're doing our y1 squiggle mx1 plus b. Once you have that, one of your options on Desmos is to plot residuals. It'll give you that third column then. On that third column, those are the residuals. It's telling you how far off the actual values are from the predicted. In some cases, the decimals go a little further. This is one of them where we had to round a little bit. Any questions on that? Out there. We're going to add a data point with a value of 13. What's going to happen to the mean? Mean value going to increase, mean value going to decrease, mean value is not going to change, or the mean value will be the same as the median value. B is correct. Y'all, there ain't really any math you have to do too much on that. Y'all, those numbers, they're all between 96 and 152, right? If we add 13 to that, 13 is lower than all those numbers, right? Mean is an average. Think about like a grade in class. Obviously your grades aren't going to be like 152 or anything like that, but if you get a score on a test that is lower than your overall grade, what happens to your grade? It goes down. If you get a score that is higher than your grade, what happens to your grade? It goes up. So same idea here. If we're taking a piece of data that's lower, it's going to bring down the average. If we have a piece of data that was higher, like if they added a 200 to it, it would have brought the mean up. Everybody kind of follow on that? Any questions? All right, go ahead and solve. Yeah, 5 is correct. All right, several different ways you could do this. You could put it in Desmos. Desmos could do it. If you put it in Desmos, you could put the left side as one line. Since you've got a number on the right side, you'd have to put y on the other side. You're looking for where they cross, and that'd be the x value. Without Desmos, because this would probably be calculator inactive stuff. Still a few different ways we could do it. The way I would do it first, I would multiply each side by 4. I get rid of that denominator if I could, okay? So then I have 2 times 3x plus 1 equals 32. 8 times 4 gives me 32. All right, everybody go with that part? I think some of y'all probably distributed first. That would have worked too, like that'd be fine. Right here, most of y'all probably distributed, right? If you didn't like the first step. So if we distribute, I got 6x plus 2 equals 32. I subtract 2. I got 6x equals 30. Divide. I got my x equals 5. All right. When I did it right there, instead of distributing by 2, I divided both sides by 2, so those canceled out. So I had 3x plus 1 equals 16. Subtracted 1. I had 3x equals 15. Divide by 3. I had x equals 5. So as I said, there's a lot of different ways you could do that depending on which steps you did and which order exactly. But if you did the steps correctly, you should end up at 5. Any questions? All right, we got to identify if each of these are functions or not. All right, so let's start with the left one here. Is the left one a function? Kevin? Yes? Can you tell me why? You're right. This one is a function. All right, that one's a function. X's are different. The x's are different. We automatically got a function. Okay? All right, middle one. Is the middle one a function? No. That one's not a function. All right, so if you remember the example I gave way back September when we did this unit, functions like a soda machine. If we push a button on the soda machine and we get a soda, we should get the same soda we got the first time. If we get a different soda, that means it doesn't work. That means it's not functioning. It's not a function. Last one here on the right. Is that one a function? Yeah. I got 7. I got a 7 again. That means it still functions. Okay? Everybody good with those? As it's been a little while. That stuff was pretty easy when we did it, but you know, that was like early September.